Welcome to this video. Here I'm going to discuss about trim. Well, trim is the difference between forward and aft draft of the ship. So suppose this is a ship and this is the water line. Well, the forward draft is this and aft draft is this. Let me define the draft. The draft is the vertical distance from keel to the water line, and this is the forward draft F, and this is aft draft A. The difference between forward and aft draft is trim. Say here, for example, the forward draft is 4 meter and aft draft is say 6 meter. Well, in this case the trim is going to be 6 minus 4, that is 2 meter by aft. Why by aft? Because this draft is more. Aft draft is more than the forward draft, or simply I can write 2 meter by stern. Now let's see another scenario. Here the forward draft is this. This is forward draft and this is aft draft. Say here the forward draft is 6 meter and aft draft is 4 meter. So we can say the trim is going to be 6 minus 4, that is 2 meter by forward, or 2 meter by head, or by head. Now let's take another scenario where the forward draft and aft draft is same. Say this is the forward draft F, which is 5 meter, and aft is also 5 meter. Well, we'll say that the draft is throughout is same, like this. Here the trim is 0 and we can say that the ship is at even keel. Now I'm going to discuss about trim cost or change of trim. Say now this is the vessel where the forward draft is 4 meter and aft draft is again I would say 6 meter. Now I shift this weight forward. By shifting this weight forward, my forward draft increases and aft draft reduces. So I will write like this. Here the forward draft becomes 4.5 meter and aft draft becomes 5.5 meter. And it will happen when the ship will look like this. So here the forward draft is 4.5 meter after shifting the weight and aft draft is 5.5. Well, let's discuss about trim cost. The trim cost is the difference between initial trim and final trim. Final trim. Well, the difference between the two is called trim cost. So here the initial trim was 4 meter and 6 meter, that is 2 meter by stern. I will just write like S. So after shifting the weight, my trim has become 4.5 and 5.5, that is 1 meter by stern. So if we see, instead of 2 meter trim, the trim has reduced to 1 meter. We'll say the trim cost is, let me write here, the trim cost is 1 meter by head. The trim cost is 1 meter by head because the forward draft is increased and aft draft is reduced. Now let us take another example, and probably the last example to explain about trim cost. Say forward, let me take this draft. Forward is 4 meter and aft let me take as 6 meter. This. So initial trim, let me write here, initial trim is going to be 2 meter by stern. Now if I shift some weight from here to here, making the draft at 5 meter. Like this. This is 5 meter. This is 5 meter. So the forward draft is 5 meter and aft draft is 5 meter. So I will write the final trim is 0, that is even keel. So well, the trim cost will be 2 meter by head. Now let us look about this vessel. She is trimming about some point like this. So this point is nothing but center of flotation. We write F. This is the point about which a ship trims. Let me write. This is the point about which a ship trims. Well, this is a sort of pivot point and the ship is going to trim about this point. Ship is going to pivot about this point like this. Now let us consider this example of a box-shaped vessel. Box-shaped vessel. Well, this is a rectangular shaped vessel like this and it's floating with some water line here. This is the water line. Now just let me remove these marks. If she has to trim, then we have to investigate how she is going to trim. Let us investigate how she is going to trim. So maybe this side, maybe this way. Well, so we conclude that the trimming is from this point, which is, let me use this color, which is this F. This is nothing but the geometrical center of this water plane area. So this is the water plane area and this is the geometrical center, water plane area. And suppose the length of this box shaped vessel was L, so this distance is going to be L by 2, half the length. Well, similarly in case of ship, if the vessel trims like this at center of flotation, this is nothing but the geometrical center of water plane area. So we may write COF is the geometrical center of water plane area. Now if I load some W ton weight here, well, there will be a movement and this movement will be trimming movement. Trimming movement is the movement which will cause the trim. So if I load this W ton here, what is my trimming movement? Well, since F is the center of flotation or as a pivot point and the distance of this weight W from pivot point is D, then trimming moment is going to be W into D, ton meter, where W is the weight loaded and D is the distance of this weight from center of flotation, and I will say by head. Why? Because this is my forward and this is my aft. So this trimming moment is going to be by head. Similarly, let's have another example where I load something here, this W ton, and the distance of this W from center of flotation is again a D. So I will say my trimming moment is W into D ton meter by stern Why? Because this is my forward and this is my aft. So this time the trimming moment cause is towards astern. Now in case of discharge, suppose if I discharge this W ton weight and discharge like this, and this is my center of flotation, while the trimming moment is going to be trimming moment is W into D ton meter, and we'll say by stern. Why? Because if I discharge something from forward, my aft draft will increase. So I will say this trimming moment is by astern. Now let us consider the example of a shifting. Say for example, here is the center of flotation and I shift this weight W from forward to aft like this. So if I shift this weight, so first step is I discharge this weight. So my trimming moment is going to be, suppose this distance is D1, so my trimming moment is going to be W into D1, and it is going to be by astern. Now if I load this weight here like this, so its distance is a D2, let's say from center of flotation. So my trimming moment is going to be W into D2 again by astern, because here in the aft draft is increasing and the forward draft is reducing. Well, the total trimming moment is going to be W this plus this. Let me add. So I get W into D1 plus W into D2, or simply W into D1 plus D2, or simply W into D. Well, what is D here? In case of shifting, D is the total distance. Let me write here. D is the total distance shifted. Now let us discuss about MCTC, which means movement to change the trim by 1 centimeter. Well, this is one of the important hydrostatic particular which is used in stability calculation. So say suppose we need this 200 ton meter of the movement which creates a trim of 1 centimeter. Change in the trim. Let me put it this way, change in the trim. So this is the trimming moment. So 200 ton meter of the trimming moment causes change in the trim by 1 centimeter. So if I say there was a 2000 ton meter trimming moment, then the change in the trim will be 10 centimeter. Well, this is pretty obvious. But this is very useful quantity. So if I say how I am getting this 10 centimeter, well, this quantity is MCTC. This quantity is MCTC. So if I divide this trimming moment, which is 2000, by MCTC, so what I'm getting? Trimming moment 2000 and trimming moment 200. So I get 10 centimeter, which is trim cost. And this is a pretty useful relationship. Let me put it this way again. The trimming moment divided by MCTC is nothing but trim cost in centimeter. Or simply I can write like this, TC. So TC or trim cost can be obtained by dividing total trimming moment divided by moment to change the trim by 1 centimeter, or simply trimming moment is going to be TC in centimeter multiplied by MCTC.